All right, let me share my screen. Again, this right here is the technical part for your project two. Again, I already did a short little video just introducing the main goal, which is to make your four different graphs. This is, again, just an example of what you're trying to accomplish. We're doing the confidence interval, we're doing hypothesis tests, we're doing confidence interval, we're doing hypothesis tests for means and for proportions. So what I'm focusing on in this video is how to do these two, right? Whenever we're doing test. So the thing that you're doing is you're not collecting new data. You're using just your data from your project one. So here's project one, and again, to give credit where credit's due, this is data from one of my previous students. Just reusing theirs as an example. And right here is where I have the data set stored. So again, your original data from your project one should have included something like this that's categorical. This is just female, male, or it's just based off of just group one, group two. If you then remember, we've got two quantitative things, and then we've also got something that was also categorical. So we're going to need a little bit of certain pieces of this. Now, the first thing that I'm going to do, if it's been a little while, is create or download a CSV file, and that's what works with StatKey. And you can see that that was already downloaded to my download files. And so whenever I go to StatKey now to make the first graph, which is going to be this one, which I believe is just the of the two, it's the one that's more just straightforward. Like, is there a difference in the means for like these two groups? I'm going to go and click on that. Then we're going to go to upload the file. And we can upload the file because we just downloaded the CSV and it's right here. And if you don't see yours right away, it's because you might need over here to find, your download folder. And then I'm going to go and click on it. And so here's the data. And the first thing it wants you to do is like, what quantitative uh, response variable are you trying to analyze? And for me, that's the GPA. Whether there's a difference in mean GPA between based on like the gender, female versus male. Then once you've clicked those, you can click OK. Now, here's what's really, really important. Once you zoom in here, this is going to be where your data shows up. It's going to have your two different groups. And then right here, this is already automatically going to tell you whether you should do a left tail or a right tail. Because this is negative, I should do a left tail. And again, what this is saying is that the group of female is lower than male by about 0.17. This is the statistic. This is what we need to get a p-value for. Now, if yours comes out to be positive whenever you're doing your graph, then do a right tail. But mine's negative, so I've got to do a left tail. And what we'll do is we'll generate 1,000. And then we're going to click the left tail. And remember, the p-value always shows up, right? As we've been doing homework stuff, the p-value of 0.025 immediately shows up, sort of as we just call it the default p-value. And that's because down here, I need to, where I see the negative 0.258, I need to update that to be what was the actual statistic that was observed, which is I'm going to do it one more time real quick, the negative 0.17. So I'm going to click on the bottom, and I'm going to type in negative 0.17. And now that I've got that in there, I can click OK. And that's going to update the p-value as it should. 0.108. And what you would do with your graph once you have updated your statistic and you got your p-value is you would put this into your project and then you would write your little what the whole test was about. All right. Again, I've got the example. I've got another video where I talk about that. In short, though, this would be a p-value that's too large so that we do not reject HO. There's not enough evidence that there's a difference between the mean that the GPA, the average GPA for female is lower than male. Yeah, there's not enough evidence to suggest that or to support that idea. But again, that's it. Like, the graph is really fast, right? Just upload your data, click your variables, generate 1,000 bootstraps or 1,000 re-randomize, and make sure you click either left tail if you're doing a negative statistic, right tail if you're doing a positive statistic, and then don't ever use the immediate default p-value. Now, if there's anyone who, when you do this, suppose that whenever you, here, I'm going to do it again just real quick. Suppose whenever you do this and you do your 1,000 and you do your left tail, if it already, like for some of you, it automatically like has your statistic already there at the bottom for you, it's not going to automatically update the p-value correct. It's going to leave it at the 0.025. So everyone just always do it. Just always click on the bottom and manually put your observed statistic down the bottom left or bottom right, depending on which side that you're using, because it won't immediately update the p-value the way that it should. Okay. Now for the other graph, that's this one here. Now, whenever you're doing the difference in proportions, you need the fractions. But what's the bummer about this one is that they don't immediately have a spot where you can upload your data. That's okay. What you'll need to do is to come all the way over here. So this is the one we're about to do. Oops, sorry, didn't mean to click that. Yeah, this is the one we're about to do this one. But if you need the fractions, go over to this one. Two categorical variables. And this one will let you upload your file and click your two variables, your two categorical variables. And then whenever you click OK, it's got the fractions for you. Now for this one, I'm specifically focusing on just this variable or this response. How many females said that social media is a negative factor? 23 out of 26. And how many males? 1 out of 6. So I don't even need this right here. I don't need the stuff about positive. I'm just focusing on how many said yes to it being negative for male and female. And since I have my rows, my male and female as my rows, another nice thing to sometimes do is this, just to real quick click on the rows, and you can see that 80, 88, almost 89% of females said social media is a negative thing, but only about 16, 17% of the males said it was a negative. Now, if you end up having your two main groups, watch, I'm going to switch the variables. If you end up having your two main groups up here at the top, then you need to read downward. 23 out of 26 females said it was a negative thing. Only 1 out of 6 males said it was a negative thing. But I usually prefer keeping it like here where I've got my main two. I don't know why, just a creature of habit. I like having my main two groups here. But remember these numbers. 23 out of 26 females said it was a negative factor. And then only 1 out of 6 males said social media was a negative thing. So here, I'm going to go take those numbers. So you need to write those little fractions down. And then whenever you come here to do your test, difference in proportions, now you have the numbers so that when you edit your data, we've got 23 out of 26 females said that social media is a negative thing, but only 1 out of 6 males. And you can put whichever group you want first or second. You just got to make sure you put the fraction for group 1, followed by the fraction for group 2, and you click OK. Then over here, you're going to see the results. Yeah, again, that's just what we saw a second ago. Female was about 88, 89%. Male was only about 16, 17. But this is the statistic. Whatever you have there in the corner is what you're trying to get a p-value for. Now, since this one comes out to be positive, we should do a right tail test. Okay, so I'm going to go over to here, and I'm going to click on the generate 1,000 of them. I'm going to click the right tail. Again, the default p-value shows up 0.025, but I need to put in the 0.718. That's the actual statistic that was observed. Now, if when you do this, see where it says the 0.308, if yours magically already happens to already have your statistic there, don't believe it. Don't believe that your p-value is 0.025 immediately. You always want to just manually click on this bottom box right here and actually put in your statistic, which again, mine is the 0.718. And ignore this stuff right here. This right here is just bootstrap stuff. This is your actual one that you're getting p-value for. So 718. 718 is what I need to put down here. 0.718. And then boom, it updates the p-value right above. So the p-value for this one should actually be 0.000. Again, if someone mistakenly just assumed that the immediate p-value of the default of 0.025 was their p-value, no, it could lead you to doing the wrong conclusion, or whenever I'm grading, I'll be like, okay, yeah, they didn't update it. But yeah, then you would incorporate this with your project. Since that p-value is really small, you would say, we can reject HO. There's strong evidence that there's a difference between the two groups with respect to the proportion who say da 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 da, right? But again, you'll do it based on the context of your study. But that's how you make your two graphs. Again, it doesn't take much time at all. I think for a lot of us, we'll probably be able to knock this out pretty quick. Again, you're just reusing the data from your project one. So again, you have everything you need. Just all we need now is time to sit down and do it and write it all up. All right, well, I'm going to go ahead and stop the recording there and get this posted and hope it helps.